VRIPS, VRIP Subnet Calculator. And what you're seeing in front of you is my dissertation instrument, and I am Douglas Bowie. And on the table is a visual representation of an IP subnet. So this is a math manipulatable for college students to learn how to divide and the mental scaffolding that would be necessary to divide IP networks into smaller pieces. It's not as easy as it sounds. It is a sort of a mental gymnastics to understand how to divide networks and set them up correctly. So in front of us, we see a chalkboard that's got a problem description. We see a whiteboard that's got a network diagram that'll go with our problem description. And then on the left, we kind of see, and as you can see, the ghostly blue hand. And as I hover over it, we'll get some information about the network itself. And we can either grab it and pick it up and move it. And this makes it a math manipulatable where we can do a variety of things with it. I can grab it with two hands and move it around. I can break it in order to subnet it. And that will break it into two pieces that I can move around. And as you can see here, we're going to assign a network into two parts. So got our solution rings over here, which is where we're going to put the network sticks. And they will change as the problem description changes. And of course, we have a main menu, which lets us reset the whole thing like that. We can choose a level to be on if we want to move forward or back. And once we have all the network sticks in the rings, we submit the network for grading, which we'll talk about here in just a second. We can also turn on and off some debug panels to learn more about what's in the rings, or we can turn scoring off if we don't want to deal with scoring. We just want to, build networks and play around. All right, so normally we would pick it up and break it into two pieces because it's asking for two parts. So we'll stick each piece into a scoring ring, and it will score them when it goes into the scoring ring. Whoops, it goes into the scoring ring. So the best score you can wind up with is 0. And that means it's completely efficient. We have not used more networks than we need to, and we do not have any extra leftover IP addresses. So each one of my network sticks here, n equals 126, and we provided each ring with 126, and by dividing it into two parts, we've done what it asked. And each ring is set up in that way. And we can submit the network, and it will say current score 0, and we'll continue to the next level. And in this case, we get 4 scoring rings, and it says break it into 4 equal parts. We get a new network diagram, and we can do things like that. And we can break each one into its own. And the network sticks will get a little smaller as they go along, but there is a minimum size, so we're not chasing around needles with text on them that would be very difficult to read, and that way they get to a minimum size, and the minimum size is not too bad. And again, we did what was exactly asked. Our need met our solution, so the score is 0. That's a perfect score. And eventually we will get to a point where the problems get a lot more difficult, and we'll divide it into 3 non-equal size networks. So we'll have one that we divide, and we will not be able to solve this one with a perfect score. It's not possible. And that's to be expected. As close to 0 as you can get is good. 0 will not always be possible. And there you go. So we created a solution. I just created a solution. It's probably not terribly accurate. I created a solution, but you can see here it does not get you a perfect score. And it will save that as we go along. And we can go and look at our score by going to submit network, and it'll show us a scoreboard. And we can go back. And we can also say restart, which will restart the entire application. We hit quit, and it'll let us leave. And we say yes and restart. And it'll take us back to level 1. And it'll blow away the scoreboard. And we can start over. This has been VRIPS. Hope you've enjoyed it.